Let me just put it back. Bring this forward. So here, what we're going to do is we're going to show how we're going to run the PGH or the simulations for the blockchain access control smart contracts that we are calling from our Raspberry Pi all the way to our blockchain access control server, which is right here. You can see here that we have started our blockchain wallet. Here it's listening at the IP address of the laptop sitting on 8545 port number, and we're running this script here that automates most of the thing. More importantly, it automates the part where I send all the relevant information that the PGH1 needs in order to interact with the blockchain access control smart contracts. So the IP address here of the PGH1, and this is the IP address of the laptop, which means the blockchain server, and the username for the Raspberry Pi. Once I press enter, I need to select if it's a PGH A or B because we have two PGH for this test bed. Once we click on A, we have a bunch of scripts running up, doing a lot of stuff. First part is the bootstrap, where it's generating accounts, generated Ganache accounts are being exported to a file. The contracts are being migrated. We are generating them, some ENV files, and there are some roles being assigned, access control contracts being deployed, default policies being added. Now with all of this done, we need to connect to our Raspberry Pi, and I need to type in my password here real quick. Once we do this, it sends a payload. The first payload is just sending out all the relevant files. The second one also sends out remaining files. And once that is done, we should have the updated files right here on the Raspberry Pi. So this is the primary group head 1, and the updated files will be stored here at the TMP folder, where we have the keys, the deployed addresses, bootstrap, and we also have the .env file updated with the new IP address, as you can see here, and the addresses, the contract addresses and the private keys are reflected with the help of the script as well. With everything up and running now, all we need to do is execute a bunch of commands here in the .env file. I've prepared a couple of things to showcase you. The first is we're going to run the npm for starting the primary head.js service. This service is the gateway interaction between the smart contracts and this Raspberry Pi. After this, we have a couple of JavaScripts which are simulated, scripts that are simulating behavior or actions from the primary group head 1 on behalf of regular members or acting itself as a primary group head. I'm just going to copy this, but before that I'm just going to update the IP. Wait, I can update the IP address maybe. So we're just going to start another terminal here, paste this. We're just so auto rotate PGH key is disabled so that we're using the same key as defined in the .env file. But in case of some errors like nonce error or your transaction exceeded, the auto rotate functionality basically ensures that we use a fresh key to simulate the network simulation. Okay, so first part is to update the IP address, which is 4.3. That's it, right? 8545. And so if we run the same script with auto rotate PGH key as 1, it rotates the key, and as you can see on the blockchain, there are a bunch of transactions are going on, and eventually the PGH simulation is complete. Here you can see the results available probably at this one. Not everything went through, but you can see here that the registered device was okay. Deployment of contract, adding policies went okay. Evaluation of access was okay. But here, one of the evaluate access for the primary group head who has a view access on a subject resource, performing an edit access got rejected, and the rest of it pretty much went through except for the evaluate edit access. You can see the gas usage for each of the transactions, and also you can see how each type of transaction accumulated for a certain amount of gas. You can also see some of the thread related information that we have derived from the thread.js module, which is a script that runs or gives PGH the understanding of what kind of actions are does smart contract support as a certain type of thread. So yeah, pretty much this is it. That's all.